This video will contain the rest of class from last Wednesday. We're going to tackle kernel density and make it work and make it make sense. So if you recall, we had this map of the world and it had all of the world's nuclear explosions over all of time, sized by their numeric yield. And we're going to look at the kernel density of that yield quantity. So let's go get the toolbox and find kernel density. We're going to put in the explosions. And for the population field, the field that we want to sort of smush into mounds, we're going to use yield. I'm going to give it a better name than this. Cadence. How's that? And for my output cell size, I think what I decided was that the default was just too big. So we're going to change this to, don't forget we're working in meters. So we're going to change this to 10,000 meters or 10 kilometers, which seems like a pretty reasonable cell size to evaluate this on. I'm not going to set a search radius. I'm going to let it take the default and leave everything else the same. And then run this. And what was happening in class was it looked like we weren't really getting anything for an output. If you squint really hard, you can see like a little purple dot here in Nevada and, maybe some light bits of stuff over here, but we just really can't see that output well. Ultimately, it's just a symbology problem. So we can go to symbology, and this is what I was able to figure out. I'm going to leave it classified, but instead of equal interval, we're going to use a quantile system with maybe 7 classes. And then I'm going to change this cutoff of the bottom quantile to 1 so that we get a difference between the background area that really has nothing in it. Maybe I could change this color to like a light gray or something. And all of the other valued areas that have some color. Now this still isn't really a beautiful symbology, but at least you can start to see what's going on here. I've decided that a great way to show this is in a 3D scene. So if we insert under new map, a new local scene, we can copy this density layer and paste it in the scene. And we can also make it our elevation layer by right-clicking on ground, going to elevation source, and choosing this K-dense as the elevation value. But the thing we discover is if we start tipping this to look at it in 3D, maybe we'll zoom in here to like the old Soviet Union, the values in the density layer are not substantial enough to really get a 3D effect. So if you remember what we did in the past when we needed to make some exaggeration, I can go back to my map and use raster calculator. Let's find, here it is, raster calculator. And I'm just going to multiply that density layer times something larger, like I guess we could try 100 or 1,000. Let's try 100. We can always come back and do this again if it doesn't turn out to be enough. Let's call it K-dense exaggerated. And I can run that, and again, it doesn't look like much. But if I copy, I don't even need to copy it, excuse me. If I just go to my scene and make it the new, oops, I'm getting ahead of my software here. Add it as an elevation source, that exaggerated layer. Now suddenly all those bumps are 100 times higher, and we can actually start to see how kernel density works. So it's taking that point explosion and it's dropping its yield off over like a bell-shaped curve. And it's 3D. It's doing it, fairly uniformly. And so it does work, and it works pretty nicely.